Hello and welcome to this video tutorial. If you are carrying out scientific research, most likely you will test a hypothesis at the end. So you need to know the right test to use for your data. Today's tutorial is a step-by-step guide on how to choose the most appropriate test to use for your data. So let's get started. In analysis, there are a number of statistical tests out there that can be used for analysis. But broadly speaking, this can be categorized into two. We have the parametric tests and non-parametric tests. So first of all, we need to understand the difference between these two types of tests. So to understand the difference between these two types of tests, we need to remind ourselves of the core reason for conducting research. The aim of research is discovering the truth about the population. You maybe need to determine the disease burden in the population. You need to know maybe the prevalence of malaria under 5 children in Uganda. But it is always impossible to collect data from all the individuals in your population of interest. So the only solution is always to collect from a representative portion of that population, which we always call a sample. So using this sample, we estimate the quantity of interest in a population, called the parameter. But the quantity we obtain in this sample is called the statistic. So simply stated, a statistic estimates a parameter. Or you could just say a sample statistic estimates a population parameter. So when we talk of parametric statistical procedures, these are statistical tests that assume that the sample distribution is about the same shape and has the same parameters as the general population distribution. In other words, parametric procedures assume that the sample that you are using to estimate a parameter in a population is a true representation of how the population actually is. So at this point, we need to note that a parameter is an assumption about the population, whereas a statistic is that assumption about the sample. So a parametric test is one that makes assumptions about the population parameters from which one's data are drawn. The parameters we are talking about here may include the mean of the population, the standard deviation, maybe you are estimating the proportion of a certain disease in the population, but you are using the sample to estimate that parameter. So on this basis of assumption, the distribution is very important. So often a population distribution is assumed to be normal. So the nature of the distribution of data should be normal. In other words, what we are trying to say here is parametric tests are based on parameters of a normal curve. Here we'll be talking about the mean of a normal curve, the standard deviation of a normal curve, among others. So parametric tests rely on the assumption that the data you are testing resembles a particular distribution. Here it is the normal distribution. And when we talk of a normal distribution, we mean a bell-shaped distribution. Therefore, if the information about the population from which the sample has been drawn is completely known through its parameters, then the test is called a parametric test. On the other hand, non-parametric tests are opposites of the parametric tests. For the non-parametric tests, there is no assumption about the population, and they are also called distribution-free tests. They do not follow any strict assumptions of a certain distribution. They are also not based on the parameters of the normal curve. That means if the distribution is skewed, you can use non-parametric test. A skewed distribution can be left skewed or right skewed. In such scenarios, we cannot use the parametric tests. The estimates we shall have gotten will not represent the true population parameter. Always remember, whenever you're doing an analysis, that garbage in, garbage out. So we don't want to find ourselves in such situations where we are presenting inaccurate data and making wrong conclusions because of the errors we are making in selecting the statistical test we are using. Before you use a parametric test in your analysis, these are the most common assumptions that you will meet. Some of these assumptions are specific to particular tests, but generally you should be aware of them. We shall be covering into the details of each of these tests in our subsequent videos. For now, let's look at the assumptions. The first assumption, like we've mentioned before, is the assumption of normality. By normality, we mean your data should roughly resemble a bell-shaped curve. When your data is skewed either to the right or to the left, the estimates you would obtain if you use the parametric tests would be inaccurate. The core element in a normality test is assumption that the distribution of sample mean is normal. That means that the sampling distribution of the mean is normal. We could also, in other words, say that the distribution of the means across samples is normal. If you have your data and you want to see whether your data is normally distributed or not, there are three tests that you could use to test for normality. The first one being Shapiro-Wilk test. If your sample size is less than 2000, you could also use the Kolmogorov-Smirnov test, or if your sample size is above 2000, you could use the skewness and kurtosis test. We shall cover this in details in subsequent videos. The second most common assumption for using parametric tests is the homogeneity of variance. What we mean here is that data from multiple groups have the same variance, i.e., we are meaning the population variance of two populations are considered to be equal. If you want to see whether the mean weight in females is different from the mean weight in males, then the variance of the weight in males should be equal to the variance in weight among the other group. So two tests can be used to check for this assumption of homogeneity of variance. We can use the Leibniz test, or we can use the F-test. F-test can only be used if you have first checked for the assumption of normality and it has passed. That's when you can proceed to check for homogeneity of variance using the F-test. But if your data is not normally distributed, but you want to check for homogeneity of variance, then you have to use the Leibniz test. For it, it is more robust. The third assumption for using parametric tests is the test of the assumption of independence. Data point values for variables for different groups should be independent of each other. And the last one is that parametric tests are used with outcome variables that are numeric, that are numbers. You can't test these assumptions on an outcome which is categorical. So at this point you can see that the choice between using a parametric test and a non-parametric test depends on the characteristic of your data. Parametric tests are often more preferred because they are more powerful and they are able to detect small differences between groups, or small sample size is usually sufficient to reject the null hypothesis. But what should you do if your data doesn't meet the assumptions for parametric tests? Firstly, you could square your data and check whether if you square, it is now roughly normally distributed. You could also try getting the tube of your data and see whether it is normally distributed. Although there are many arguments about this transformation of data, but it is also generally accepted in the scientific society. Secondly, if your data doesn't meet the assumptions of parametric tests, you could use the parametric test anyway. However, you need to give valid reasons as to why you are using the parametric tests. Always also remember the central limit theorem, whereby we fulfill the assumption of normality for small samples if the data is fairly symmetric, and if the distribution is skewed, we need a larger sample size to approximately become normally distributed. But if the distribution is highly skewed, then the non-parametric tests generally have greater power because they are more robust against extreme values. And even where most of the data values appear to be normally distributed, but they are extreme values which are very far away, still you should use non-parametric tests because the parametric tests are very sensitive to these extreme values. So in our next part, we shall be looking at the different parametric and non-parametric tests and the conditions under which we can choose which one to use, and also which alternatives of parametric tests can you use. So see you in the next video.